I'm bored.
All right, a couple of reminders again, ladies and gentlemen. Good news, you won't be hearing these much longer from me. Last day for missing work, retakes, missing labs, anything like that is Thursday, the 20th. That is 2 days from today. On that same day, you will have your Unit 4 test. It will be a short test. It is 10 questions, about 25 points, 26 points. So not near as big as the other tests that we have done. Next week on Thursday will be your final exam from 9:15 till 10:45. Questions on any of that? Okay. Yesterday I left off with a problem where I showed you why we have to find a precipitate, ladies and gentlemen. And here was the reason for that. If you do not find a precipitate, ladies and gentlemen, in a reaction, what it means is if something is aqueous, it will break apart into the ions that make it up when it is placed into water. When that happens, ladies and gentlemen, all these ions do is float around in water, waiting to combine with some other ion to make a precipitate. If they don't find one, they just stay floating around in the water. So in reality, in this reaction, nothing actually happens. The magnesium that's ions at the start is magnesium ions at the end. The nitrate ions at the start are still nitrate ions at the end. The lithium ions here are still lithium ions here. And the hydroxide ions are hydroxide ions. In this reaction, nothing would happen. You could literally cross everything off that is the same on both sides and you will be left with nothing. Nothing. That means there's no reaction. Now let's take a look at what happens when there is a precipitate, ladies and gentlemen. Okay? You don't need to do anything but sit and watch. Okay? Sit and watch and listen. This reaction creates a precipitate. Here it is at the very end. This is the one that we did yesterday. Now, if I do to this one what I just did to the last one, it comes out slightly different. Not very different, but slightly. Now, again, anything that is aqueous, we could take and break it up into the ions that make it up. So 3 magnesium plus 2 ions that are aqueous, plus 6 hydroxide ions that are aqueous as well. And if you're wondering where I got the 6 from, ladies and gentlemen, the 3 out in front multiplies by the 2 by it. That gives me 6 of these. Okay? So this has to create this balanced set of ions. 3 magnesium, 6 hydroxide, 6 hydroxide. Any questions? Now this is also what would happen if we were to put this compound into water. So we talked yesterday, what happens if you put it into water? It either stays aqueous and breaks apart into ions, or it is a precipitate and it will settle. Okay? So now we go to our next compound. Our next compound would have 2 aluminum ions, plus 3s that are aqueous. And it would have 6 chlorines, again that are aqueous, charge of a -1. Again, the 3 here and the 2 here give me the 6 that is in front there. Any questions on that? We would create, again, 3 magnesiums plus 2 ions. They would still be aqueous. And 6 chlorine -1 ions that are again going to still be aqueous. But now, ladies and gentlemen, because this is a solid, this stays together. This stays together as aluminum hydroxide. solid. Now we have something on that side that we do not have over here. This is called an overall ionic equation. We have taken everything that is aqueous and broken it apart. Now this is a double replacement reaction. I am not asking you to do this. I'm just showing this to you. Excuse me. Mr. Brandon? Not here today. You're welcome. Okay. So, now, in my day, ladies and gentlemen, I will tell you just a quick little story. I hated reading. Still not a big fan of reading. For somehow, in school, I got put into an accelerated reading program. So I learned one thing really quickly. Be the second person to talk on reading day. Okay? I was the second person to talk. And my speech went something like, I agree with Lily. Jimmy in the book is an awesome character. He does a lot of weird things, but he's kind of quirky, and that got me out of ever having to say anything else again during reading time. Okay? So I faked my way through reading most of the time. I was a slow reader. I didn't like to read. Wasn't good. Now, occasionally, the teachers would make you do a book report on something. Now, if I couldn't find a movie that was the same title as a book, I had to do my second best choice, which was go to what were called Cliff Notes. Anybody know what Cliff Notes are? Today, I believe you call them Spark Notes. They're a short summary of a book so that you can get the general idea behind it. Okay, saved me on a lot of book reports. There's a lot of stuff there. We're going to get this down to just what matters. We're going to get down to the Spark Notes, to the Cliff Notes, to just what's going on in this reaction. And what I mean by that is anything that is the same on both sides of the arrow, exactly the same, I am going to take and I am going to cross it off. So that means this gets crossed off because it's the exact same as this. That means this gets crossed off because it is the exact same as this. And that means what really happens in this reaction is 6 hydroxide ions that are aqueous combine with 2 aluminum ions that are aqueous and create 2 aluminum hydroxide compounds. That's what this reaction boils down to, ladies and gentlemen. Out of everything that is there, this is what this reaction actually is. And this is why we need to find a precipitate. Because without it, nothing happens. Everything just stays aqueous. There are no changes. There technically is no reaction. Think back of when we had our acids and we added them to our metals. There were one where there was no reaction. You put acid with copper, it did not react. Everything would have stayed aqueous. There was nothing new created. But when you put the acid with magnesium or when you put it with zinc, we got something different. We got an actual reaction. Well, here's an actual reaction. Questions? Okay. All right. So, for today, ladies and gentlemen, to start out, let's take and you tell me what happens to these 4 compounds when they are placed in water like we did yesterday. So begin by writing the compound. Write the formula for the compound. Just as if I had said, write this formula in Unit 3. Then draw an arrow, put water above it, and tell me what happens to that compound. Does it break apart into ions and become aqueous, or does it stay a solid and settle out of solution? If you have questions, ladies and gentlemen, please call me over. We will give you 8 minutes to get this done. That's 2 minutes apiece. Should be plenty of time. Okay, Ethan?
No.
What's the matter?
He doesn't have any shoulders.
And how is that bad for you?
He's frustrated with me not being able to find him.
His back making noise.
You're frustrated that he can't find stuff.
Yeah.
Why was you yelling at me?
He's looking at this kind of
Okay, no, because you're gonna be putting a 1 by it.
The only time you put it in parentheses if you're putting a number like a 2 or a 3 outside it, yes.
So even if it was like just CO with the 2 outside of it?
Well, remember that the polyatomic is going to be CO2, CO3, could be CO, because it could lose oxygen. Once you determine what that polyatomic is, you're never going to change that. So now, if you need more of them, you put that polyatomic in parentheses, whether it's CO, CO2, CO3, whatever, and then the number outside would be the charge of the other thing that it's with. Okay?
Wait, I'm confused.
Just what we did yesterday at the start. Remember how we took the compound and we said, okay, find it on here. Is it aqueous or is it a precipitate?
Okay.
If it is aqueous, you're going to take that and you're going to do what I just did in that balanced chemical equation. You're going to break it down into the ions that make it up. But if it's a precipitate, all you're going to do is rewrite the formula with an S5.
Okay.
Because that's what happens. It either stays together and it's a solid, or it breaks into ions and it is aqueous. Okay? Yes, ma'am. Okay, so now, where's your team sheet? You go to this side. Find me CO3 on here. Okay, so CO3 is normally going to be a precipitate with most things, unless it happens to be with one of these exceptions. So it's with an A, correct? So is an A cation?
But it's not in.
That means it's in the group
Stop
one.
overdoing A's.
Okay. So because of
This,
that,
I'm just doing this because
instead of being a solid, it will instead be a precipitate. Or I'm sorry, instead of being a solid and a precipitate, it will be aqueous and break apart into ions. So now show me that breaking apart into ions.
How does it break apart into
Okay? So break that apart into ions like I did just a minute ago on that chemical equation. And what 2 ions make that compound?
It's without that count.
How many is?
No.
2 of them, and what's their charge?
So I can erase.
You write it like Na plus 1, like as if you were gonna write the formula. Nope, you just put a 2 in front.
No, but like when
That's not a,
when it's 8.
no. That 3 is part of that CO3 group, so you don't have to touch that. Now, if that group were in parentheses, and there were number outside, then that number would go in front. Since there's no parentheses, you just write it CO3. Put the charge up above like you did here, and then make it A. AQ. You put AQ. That means by both of them.
Oh.
There you go.
So it's aqueous, right?
That's what
So
happens.
then it's literally just NA AQ.
So confusing.
Well, you gotta realize that there's 3 different tables there.
Yeah.
And that bottom table, most of the time, those things are going to be a precipitate, unless they happen to be with the exception. In the second table, most of the time, they're aqueous, unless they're with the exceptions that make them a precipitate. So, yes, ma'am.
So I'm trying to do all of this, but what do I turn it into?
Okay, so if they're aqueous,
we go back to writing them like the ions that we originally did to make up the compound. Okay? So, since this is gonna be aqueous, what is the ion for sodium? In other words, write sodium alone, but make it an ion with its charge.
This just,
So what would be the charge of Na? So that's the way you write it, Na plus 1. Now, one last thing though. Since there are two of them here, that 2 becomes the coefficient in front. Okay?
doesn't carbonate
So
react.
now we put AQ after it.
If
To
it's,
tell people
in
it's
this
aqueous.
section,
Plus,
if it's in.
what is the
if it
other
applies to
ion that
this,
makes
then
up
it's
that compound? Okay, so we write the carbonate ion. Nope, the 3 is part of that polyatomic. No, because we didn't put a number on it. So, since there were no parentheses though, that means there's only one of those CO3 groups there. So you don't have to put a number in front there. If there were parentheses with it, that number by the parentheses would go in front as a coefficient, just like the 2 did for the Na. Yep, and then AQ.
I don't think.
Why? Well, that's right. This is right. I'm confused here. Well, you haven't finished it yet. Well, kind of. Where did you? Okay, first of all,
Oh, yeah.
that 3 will be what goes in front here because it's outside of the parentheses. And then what's in the parentheses is what you put after that 3. Okay? So this is what you write next, but then don't forget its charge.
I don't have to multiply by 3,
Well, you are by putting the 3 in front.
but I don't like to do 6.
No, you don't, we don't ever change these groups. Okay? Now, if you were adding it up to balance it, yes, it would mean 9 of them, it would mean 6, you know what I mean? You'd multiply by 3. But for this, we're just saying we have 3 of these polyatomic groups. Okay? So list the polyatomic groups. Yes, ma'am? Precipitate, yes? You would write it exactly as it is here with an S.
Isn't it?
You would write the compound just the way it is, and you would put an S
I'm
by it.
not telling you. You said it was an aqueous. Yes, the first one is an aqueous, but once you translate it into a precipitate, it's not aqueous. You're translating it into a precipitate. That's what you told me.
Okay. I don't know if she's using the right term to translate it into a precipitate, but here's the thing. Every compound in the world, okay, is either aqueous or a precipitate. This table helps us find the most common ones as to which it will be. So, for lithium phosphate, Li3PO4, here's PO4. Now, normally PO4 will be a precipitate with most things, unless it happens to be with ammonium or the cations of group 1 except for lithium. Well, since the lithium is here, that kicks it back over to here. You understand that? So that means that this is going to be a precipitate, a solid. Which means if you put it into water, nothing is going to happen to it. You just rewrite the formula exactly as you have it, and you put an S by it. That's what that means. So that is correct. Yes. Okay? Now here, this one, because it was carbonate, and because it was with sodium, the cation of group 1, it will break apart. Now, here's the only thing. You need to tell me what the charge of Na is up here, and you need to tell me what the correct charge of CO3 is here. Na is a +1, yes, but you need to show me that +1 above to show me that it's an ion, okay? And you need to correct the CO3, it's not a -4 charge. Yes, correct. Yeah.
And what about?
Please add the aqueous. That's the only thing. Okay, does this precipitate? Okay, that means we rewrite it like we did, or like we should have this one. The precipitates, you just rewrite the formula literally the way you wrote it the first time and put an S by it. Because that's what happens when it stays together. No.
You?
Yes.
So you write this, and if you split it. Because
It's not a full details.
No,
CR04.
he's trying to split it.
Okay.
I knew it.
Okay. Do anything. I understand that, but you realize that would be a mistake that I would
No,
have.
it's because he split the whole thing so we can
It's
see
the same way.
Yeah, that's what I'm talking about. He's saying we have to split it.
I don't
Here.
know. It's all confusing.
You've got to tell me that this is there, and you have to put a plus two. Charge would be a plus. This would be, wait, yes. Two though, you copied it down though. It's supposed to be a two. So then you put a plus two here, and you put the aqueous here. This three you did perfect there, but make sure you click that this is a minus one, polyatomic, and then it's aqueous.
Oh, what is for two then, since the charge is two?
Correct, so again, that was the, I'm sorry, I caught up on a couple of mistakes. This should have been a plus two, which means that should have been a two, which means that should be two. Now, the good news is what you're doing, you're understanding and you're fundamentally doing is correct. But we gotta get that formula right to start, otherwise you're gonna have problems. Do you understand what I mean? Okay, good. Okay. Yes, ma'am. Okay. Here's what here's what's there. You're doing a good job. Not quite flowers.
What part?
This would be PV plus two. That's what you would write. You would write three,
Yeah,
two,
it's
and
always-
O2, that is a minus one. Now
Like
you
just
write
like
it.
what we just that. And then you're like, this should be.
You gotta get that every time. Every time you gotta do this.
Oh wait, no.
Okay. All right, so please listen, ladies and gentlemen, and let's go through this. One of the things I want to stress to you is you need to write good compounds. And that is not just for right now. Okay? Unit 5, which you are going to go to at the start of the next trimester. Unit 5 is figuring out something called formula mass. The mass of a compound. The only way you can do that correctly is if you write a correct formula. So if you write wrong formulas, you are going to get wrong formula masses, and then you are going to get wrong answers from that. So this is an important thing. Now, 90% of the time, the compounds that we are talking about, and the ones that we are talking about here, are ionic compounds. Okay? This whole sheet is based on the fact that these are ionic compounds. A single replacement reaction is based on the fact that you have an ionic compound and a lone element. A double replacement reaction is based on the fact that you have two ionic compounds and you are going to create two new ionic compounds. Now, in a decomposition, in a synthesis, you may create something like carbon monoxide or carbon dioxide or dinitrogen tetraoxide. Those have prefixes in them. Those are now covalent compounds. Covalent compounds, we don't worry about charges. There is no +1, no -1, nothing like that. Covalent compounds are written by that name. Dinitrogen, N2. Tetraoxide, O4. Okay? So there is a distinct difference there. And most of the time you will be working with ionics. So one of the things you need to remember is to write an ionic compound, you have to write the formula and the charge. and then crisscross them to get a total charge of 0. Always. Okay? Now, part of this is when you do that, you may go back and undo it right away. Why? Because the compound may be aqueous and turn right back into those ions that made it up. Okay? That could happen. But on the test, I am going to give you a point for writing this correct formula. A point for just writing the correct formula. And then you're going to get 1 point for telling me what happens to it. Does it break apart or does it stay together? Okay? So the reason I'm asking you to write the formulas is so that we get those down first. Okay? So sodium carbonate, ladies and gentlemen. If we are writing the formula for sodium carbonate, I got to get to my ones for today. Hang on 1 second. Okay. So here we go. Sodium carbonate. I need to write a formula for that. Sodium is Na. Sorry. Sodium is Na and it has a charge of +1. Carbonate is CO3. That might be the worst CO3 I've ever written. And it has a charge of -2. As a compound, that is going to be Na2CO3 like that. Why? That is the way that our charges balance off to be 0. +1, -2, bring the 2 down there. Now, I am never going to change this CO3 group. This is my polyatomic. I'm not going to change it. If I want more of these groups, I have to put it in parentheses. Okay? So I'm never going to change that CO3. If anything, I'm going to put it in parentheses and put a number outside. But I don't have to. Why? Because this was a 1. Any questions on this compound? But these are the steps you need to go through, ladies and gentlemen. Now, if you are good enough to where you know the charges and you can do this stuff in your head, more power to you. Do it that way. But if you're not, put the charges, do your crisscross, make sure you get this compound correct. Because believe me, in the next unit, and the unit after that, and the unit after that, if you write this formula wrong, you're going to get your problem wrong. Okay? It is that important. All right? Questions? So now you go to this sheet. Now here comes the next step. You know how to write the compound. Do you know how to use this side of this sheet? Okay? To use this side of the sheet, I look at the polyatomic anion, the CO3 at the end. I find CO3 on here. It's the second one from the bottom. CO3 normally precipitates with things. With most cations, it will become a solid. There are some exceptions, and that's in the middle. Those exceptions are ammonium, NH4, and they are the cations of column 1 except for lithium, which means not lithium at the top, but sodium, potassium, rubidium, cesium, and francium. Why not sodium? Because it doesn't dissolve. It's just the facts. It doesn't dissolve with that one. It is too reactive. It makes a precipitate and it settles out of solution. I'm sorry. I wish it didn't do that, but it does. Chemistry is a lot of exceptions. I'm sorry about that, but there's nothing I can do about it. So because it is with sodium, that means this is going to be aqueous. Hopefully you understand how we get that out of here. If not, you better come and see me because we're using this all second trimester as well. Okay? So if you don't understand it, we got to come and we got to get you to the point where you do understand it. Because of that, ladies and gentlemen, if I put this into water, that means this is going to break back apart into these things over here that made it up. Now, it's going to break apart into a sodium ion, but there are two of them here. So this 2 after the Na ends up going in front of it here. And we put AQ for aqueous. Yes, all of this needs to be done. The 2, the +1, the AQ at the bottom. Plus carbonate, CO3. Now, there were no parentheses around this. That means there's only one of these groups. So I don't have to put anything in front because by putting the group, there's one of them. But I do need to put down that this is a -2 ion, and I do need to put down that it is aqueous. And that is what I mean when we say, if something is aqueous, we will break apart into the ions that made it up. And that's what this is. These are the 2 ions that go into making up this compound. Questions? We're good. I'm telling you, there are 4 problems like this on your test. Just like this. And it says the same thing at the top. Tell what will happen if you put them into water. And what I'm expecting to see is the formula, an arrow, and then what happens. That is what I'm expecting to see. Questions? Okay. Now let's go to lithium phosphate. Jade, give me the formula for lithium phosphate, please. Give me the formula that you wrote down. Jade, that's perfect. Lithium is a +1. Phosphate is a -3. That gives us this compound. Okay? Lily, when we put this into water, will it dissolve and be aqueous, or will it precipitate and be a solid? Okay, and this is one that's on the bottom, ladies and gentlemen. And PO4 normally is a precipitate with most things. The exceptions being ammonium, sodium, potassium, rubidium, cesium, and francium, but not lithium. So Lily is absolutely correct. This is a precipitate. So I am just going to rewrite my formula exactly as Jade gave it to me, and I'm going to put an S by it. And I am done. Finished, complete. Questions? Any? Okay. I need a formula for lead 2 acetate. Jalen, can you give me the formula for lead 2 acetate? Okay, acetate. So when we create a balanced compound out of this, what do we get? Whoa, slow down. You're getting ahead of me. What I want to know is, see how we wrote these as a formula first? What would this formula be? Before we get into saying, okay, is it aqueous or is it a precipitate? So what would this look like as a complete formula? Thank you. There you go. That was what I wanted first. Thank you. Okay. Now our next question is, does this precipitate and become a solid, or does it break apart into ions because it is aqueous? Linda, what happens? Is it aqueous or is it a precipitate? All right, it is aqueous, okay? Now, with acetate, there is only one thing that will precipitate. One thing, and that is silver. And it is not with that. So now we are going to go and we are going to break this apart into ions like we did at the very top. Okay? So, what are the ions that make this up, Alan? How many of them? No. Is there a 2 by the lead here? But it does have a what? Thank you. I think you got those confused. Okay? Lead is a +2 ion. But there is only one of them in this compound. Okay? There's no number by the lead. Now, what do I put by this, Alan? AQ. Plus. All right. What's the other ion here, Alan? Okay. C2H3O2. Charge. Okay. Anything else you want to add to this, Alan? So where does that 2 go? Okay, in front of the formula. Very good. Anything else, Alan? And it's aqueous. Very good. So, this is the way, ladies and gentlemen, we would write this. Pb +2 aqueous plus 2 C2H3O2s minus 1s that are aqueous as well. Questions? All right, barium chromate. Barium chromate. I need a formula for that. Okay? Need a formula for that, Stephanie. BaCrO4. Now again, a minute ago I told you, I don't care how you do it as long as you get it correct. Stephanie got that correct. But for those who are wondering why, Ba is a +2, CrO4 is a -2, therefore that gives us BaCrO4. Perfect. Questions? All right. Jonathan, is this a precipitate or is this an aqueous compound? All right. So that means that it is going to be a what, Jonathan? What is a precipitate? A what? So what do I do to this, Jonathan? I write it exactly as it is here with an S by it. Questions? We're a week away from being done, ladies and gentlemen. A week away. Okay? And you've got 2 more things to do for me. You got to take a short Unit 4 test, and you've got to do a lab where most of the work you will do before you ever go into the lab. Okay? But here's my point to you. The second semester gets a little bit tougher because, 1, there's a lot more math. And 2, we are taking what we learned and we are applying it. So I am going to, in the second trimester, next try, the 3rd try of our school year, I'm going to expect you to know how to write these formulas. I'm going to expect you to know what happens if we put them into water. I'm going to expect you to be able to write a balanced chemical equation. Okay? Now you guys have an advantage. You just did that. I have 2 classes full of students who have had 12 weeks off. Sucks to be them. It really, really does. Now, am I going to review some things at the start of the next try? Yes, I have to. So some of you are going to be in here going, oh my God, we just went through this. And oh my God, he killed me the last week talking about this stuff. Now here he is doing it again, and I'm sorry. But I've got to catch up some students who haven't had this class in 12 weeks. But here's what I'm going to tell you. The second part of this class comes down to a lot of practice. And I give you practice time in class, and some of you do an awesome job of going in back and working on things. And then there are others of you who use the time to kind of practice, but more or less talk with other people. And if you can get away with that and you're understanding things, that is great. But if not, ladies and gentlemen, you need to seriously try to put more effort into the class time here. Why? Because the only other option I can give you is if you won't put it into the class time here, you have to come see me outside of class time. Okay? And most of you don't want to do that. I don't blame you. I don't blame you. But this is about your grade in this class. And are you going to do what you got to do to get it to where you want it to be? Okay? So again, tomorrow I'm going to go through a few more of these with you. And if you've got it and you're bored, I'm sorry. But if you're struggling with it and you're sitting there and you're going, man, I'm still not sure where he got this or where he got that from, and you don't say a word, I cannot help you. I cannot help you if you won't ask me questions as to why I did something or how I got something. And here's what I'll tell you. I can almost guarantee you, if you're sitting there with that question, somebody else is sitting in the class and they're too afraid to ask as well. So someone's got to do it. Last problem for today, ladies and gentlemen, then I'm going to give you time to work on things. Here it is. Maybe, if I can get my thing to work correct. Aqueous lithium sulfide is mixed with aqueous gallium bromide. I want you to write a double replacement reaction, and I want you to balance it if the reaction does in fact happen. There is absolutely no reason for you to check the reactants. I'm telling you they're aqueous. Telling you that. So you need to write the reactants. You need to switch the metals, what they're with, and see if something precipitates. And by the way, ladies and gentlemen, I don't know whose it is, but I found this in the lab this morning back at that back station. So if you lost your periodic table and your solubility chart, here you go. So that's why you couldn't find them in that folder.
Yeah.
You didn't lose the folder, you just lost the stuff that was in it. There you go.
And then bromine is these exceptions. Good news, everything you wrote down is good. I don't know if you balanced it. That's the other thing. If it does happen, you gotta balance it. Yes. Yep. Good. Okay. Okay. So this is a double replacement reaction.
Oh, yeah.
Okay. Good. Go ahead. No, I can-
I don't have this place.
You don't. You switch lithium and bromine. Okay, I don't know why you have this up here.
I didn't center it and I got mad, so I didn't.
Okay. So this is fine, but here's the one thing you have not balanced this compound as well. So like here, you know lithium is a +1, this is a -2. I'm assuming that's how you got the Li2S. Here, you got +3 and a -1, that's how you get this. Here, you assume that this was going to be the same basic formula as this, but it's not. This is a -2, this is a +3. Let's write a good formula for that.
I'm just missing the 2.
Well, you need to write the complete formula. Below there. What I mean by that is, that the 3 goes down here, the 2 goes down here. Yes. Now here, what's the charge of Li? What's the charge of bromine? Okay, so let's correct it. That's writing that correct formula that we're talking about.
And then I just do a scoreboard thing.
Okay, did you find a precipitate? Slow down. Look at the two products that you created, and let's make sure this reaction happens. For that, you look at GANS. Okay. Okay, that precipitate. How about LIBR? These are normally aqueous, unless there would be an exception. Li is not an exception.
So this is
Correct. Correct. But now you do have to balance it, like you said, because you did find something that precipitates. Only, that's all you're gonna find. You're only gonna find one precipitate. Unless I messed up big time, there should only be one precipitate, the other one should still be aqueous. Well, if they were both aqueous, you would write no reaction. You've got to find that precipitate or water or a gas. Now, I'm not going to give you any with gas. I guarantee you that. And on a test, I wouldn't give you any with water. I did on one example earlier with that. So you're normally going to be looking for that precipitate. Okay? Yes. AQ, S, AQ. 3 of these 4 are going to be aqueous. 1's going to be a solid.
I think this is like I got 9 I2 S 6 GA 3 GA2 S3 and then 18 don't know.
Those are the reasons. This plus this.
It's a lot
What's the charge of GA? The charge of S.
I did something really wrong. not that it's wrong, it's
Yeah,
too
it's
wrong.
Well,
It's, you could have done it.
what you did there was perfect, except for one thing.
What is it? I got 18.
This is bull.
Nice.
Bob.
Six guys.
So here's, so 18 robots. And it is
And it's a
normal.
wow.
8.
I
did it.
I think I did something.
And I didn't even have to do anything. So good at this.
Yes, you
Okay. And this.
No more wrestling for
It
you.
was always nice. I can do it when I'm like.
It's normally aqueous with most things.
I know the game.
You get 32.
Yes. Not really, but yes.
Well, I just love lithium bromide for second hand. Yeah.
Extra? You wanna like,
Yeah, so your spot.
you'll play saxophone now? Then you have to zero.
Yeah, I guess. I can sacrifice that.
Right.
What's gonna do?
Yeah. That's the cat. That's the DA and that writer. You catch it. Okay? It's not about the cheating, it's about the that's the so I just cross these. You just overcross it. Good. You're gonna put it down and then put it where you're at.
This is
You
also.
said 99.9.
Oh, now he's
What if I got 18 lithium and 18 bromide?
Why did you?
Okay, now, here's the thing. I want to show you something. 9, 6, 3, 18.
That's horrible. Oh, they're
The
halves.
thing-
They're halves.
No. 9, 6, 3, 18. Somebody tell me about 9, 6, 3, and 18.
They're numbers.
Wow.
They're halves.
What? They're all divisible by 3.
Mm.
You missed the lowest form of balancing this. Yours is balanced. But you now got to reduce into lowest forms.
Okay. At least I was in the
At
ballpark.
least you were in the ballpark.
At least I was in the. Hey, that's what counts. By 18 lithium, 18 bromide. So how do I do this?
Yeah.
But you got 9, 6,
So now it's like
3, 2, 1, 6, 3. What's 18 divided by 3?
Now write the
What's 18 divided by 3?
18 divided by 3?
Right now, you make everything in the
Yeah, right.
Let's make it look like the equation. Let's put these two things.
Wait, so. Can I see?
How hard is this?
Okay, yeah, no, yeah, I could. I mean,
No, just divide your 2 by 3.
Yes.
He's struggling.
I got it. Yeah.
No.
I'm looking at my face.
Bromine has a charge of -1. What do you put it? You know what? Well, yes, you
No.
there's gotta be a cation.
Have it at all.
Or a metal.
Oh, but just drop it. Just drop chemistry. It's so
Okay, what's the charge of gallon? You got a +3 and a -1.
I think I have it.
Well, that's not even
Please.
Well,
Please, I'm sure. Please, I'm sure.
You're working on the board.
You need to get on board.
Because it's supposed to be.
We're gonna love this.
She said it was a little exit.
Yeah, no, I went through all the sides today, and you're supposed to have body paragraphs. She said it. So not a formal essay, but like. But you don't write a formal essay.
Not at all.
It's a two. So then what's the difference between an essay and a formal? Because you don't have a conclusion.
Next thing.
She's like, you don't write.
Either one of these precipitate. Check or precipitate.
All right, ladies and gentlemen, let's get this done so that we can finish this up today. Okay? So, Divine, headphones, please. Thank you. So here we go. Okay? Again, writing good compounds. Lithium sulfide. Lithium is a +1. Sulfur is a -2. So that is Li2S. Aqueous. Plus gallium, Ga+3. Bromide, Br-1. Gives me GaBr3. Aqueous. Questions on this? They're going to react. Well, the only thing that can happen in a double replacement reaction to get two new things is the metals or the cations, I don't care which one you want to call them, have to switch places. Have to switch what they're with. What that means is that lithium is going to go with bromine. But remember, lithium was a +1. Bromine was a -1. So LiBr is our formula there. A +1 and a -1, crisscrossing them, that's our formula. And then gallium is a +3. Sulfur is a -2. So we end up with Ga2S3. To balance off the charges on each of these compounds. Questions? Okay, now we check this sheet for a precipitate. Does either one of these precipitate? Which one, Lily? All right, so this is going to be a precipitate. That means this is going to be aqueous. That means this reaction actually happens. One last thing to do, what is it? Balance. So, LiGaSBr. 2 Li's, 1 on the product side. 1 Ga, 2 on the product side. 1 sulfur, 3 on the product side. 3 Brs, 1 on the product side. Now I'm going to start balancing. I don't care what you start with, ladies and gentlemen. Okay? I don't care what you start with. I'm going to start with lithium. I'm going to put a 2 in front here, get it balanced, but now that only gave me 2 bromine. I know that's going to be a problem. Okay? But again, you can move on to something else or not. I'm going to move on to gallium. I'm going to put a 2 in front of the gallium on the reactant side to get 2 of each. And now I'm going to get 6 bromines. Okay? So, now I have a couple choices. All right? I'm going to keep working with the ones I haven't done yet. Sulfur. 3 on one side, 1 on the other. So I'm going to put a 3 in front here. That gets me to 3 sulfur. And it also gets me to 6 lithiums. Which means now this 2 that I put in earlier is too small. So I'm going to take it out and I'm going to replace it with a 6. 6 and 6. Now, you will not get this to balance. if you do not get these subscripts correct in your formulas, if you make this GABR2, this is probably never going to balance for you. You can spend hours, you can spend weeks, it will not balance. If you're getting to the point where you're like, man, I cannot get this to balance, I cannot get this to balance, my suggestion is to go back and check your formulas. You probably wrote one wrong. And because of that, it is not going to balance. That is just the way it works. Yes, sir.
So if we balanced it too high, would you still mark it wrong but still balance?
It's still going to be balanced, but you're going to lose 1 point of your balancing because it has to be in lowest terms. It's kind of like, you know how these need to be in lowest terms because they're ionic? So does your equation. Here's the other thing, though. We do get to some numbers like 6. The only time you're going to get to like 18 to 13 to big numbers like that is in those ones where it's C3H8 plus O2 producing carbon dioxide and water. You're going to get to some big numbers in there, but that's about the only one. Okay? So if you're on to 18s, man, you probably missed the lowest one. Now, again, that doesn't mean that I wouldn't continue to balance. You continued to balance and you got it balanced. But then go back and look at your numbers and say, okay, 6, 3, 9, and 18. Can I reduce those? And if you can, all you do is divide everything by the smallest number or reduce them by whatever number is possible. And you don't have to redo everything. You just need to reduce it. Okay? So then it comes down to 3, 2, 6, and 1. A little better. Okay? A little better. Questions? Okay. Tomorrow is our last day before our unit test, ladies and gentlemen. Tomorrow, I have 3 more practice problems for you, just like we've been doing. But what I'm going to do is I'm going to print them out. I'm going to put them on the back lab stations so you can come in and you can do them as quickly as you want. We're not going to wait for the entire class, okay? And then you can go on to working on things in your packet or asking me questions or things that you need to get you ready for your test on Thursday. Okay? So that is the plan for tomorrow. Again, I have another problem just like this. I have another problem like the ones before, and I have a single replacement one where I said, okay, does this react with this or does this react with this? I will print those out for you for tomorrow. They will be sitting back on the lab stations. I will put answer keys in the middle for you. You can spend the time doing what you need to do to get ready for your test. Questions? Okay.